Hello students, this is the second part of the chapter electricity class 10. In first part we have studied what is electric charge, the type of charges, the properties of charges, the SI unit of charge, the definition of 1 coulomb, the charge on 1 proton, charge on 1 electron, and the number of electrons contained by a body having 1 coulomb charge, and the difference between conductors and insulators. Now in this part, in this video, we are going to start with the difference between static electricity and current electricity. Static electricity and current electricity. These are two different electricities. In static electricity, electric charges remains at rest, and in current electricity, electric charges are in motion. Second difference is static electricity damages everything, and hence it is not useful. Not useful means it is harmful. But current electricity is useful. Third difference is we can take the example of static electricity as the electricity. First of all, we should take example before going to explain the third difference. Example is lightning during a rainy season. So this type of electricity which is observed during rainy season is the static electricity, and we all know that it is very harmful, and this is useful because it is used in all the electrical and electronic appliances. Now the third difference is that static electricity does not flow in wires, but as in case of current electricity, it flows in wires. Now we will talk about electric potential and potential difference. What is electric potential? Electric potential is the work done in moving a unit positive charge from infinity to a point in electric field. This is the definition. Means, suppose this is the electric field which is represented by vector E, and there is a charge Q at infinity, and we have to bring this charge at a place, at a point. Suppose this point is P. We have to bring this charge from infinity to the point P. Then we have to do some work in transferring this charge from infinity to a point P in electric field. Let this work done is represented by capital W and charge is Q. Then electric potential is represented by V, which will be equal to V is equal to W upon Q. So based on this formula, the definition is derived. It is the work done in moving a unit positive charge from infinity to a point in electric field. Q is the unit charge. Unit means 1. It is 1 coulomb. It is assumed that it is 1 coulomb. Now, if work done in bringing 1 coulomb charge from infinity to a point in electric field is 1 joule, charge is 1 coulomb, then electric potential V will be equal to 1 joule upon 1 coulomb. So 1 joule upon 1 coulomb is 1 volt, and this is the potential. This is the electric potential in transferring a 1 coulomb charge from infinity to a point in electric field, and 1 joule of work is done in transferring this charge at that point. Now, based on this, we can define 1 volt. How we can define? A potential of 1 volt at a point means 1 joule of work is done in moving 1 unit positive charge from infinity to that point in electric field. This is the definition of 1 volt, which is based on this formula and this expression, and this expression is based on V is equal to W upon Q. The potential, electric potential, is said to be 1 volt only and only when 1 coulomb charge is transferred from infinity to a point in electric field, and 1 joule of work is done in transferring this charge from infinity to that point in electric field. Now we will talk about potential difference. There is very small difference between these two. This is potential difference is work done in moving a unit charge from one point to other point in electric field. Suppose this is electric field, vector E, it is represented by vector capital E. And suppose this is a point where charge is kept, this is point A, and this charge is transferred to point B. So a work is required to be done to transfer this charge from point A to point B. So work is required to be done, and hence the work done in moving a unit charge from one point to another point in electric field means this charge is transferred within the electric field. And this is the main difference between this electric potential and potential difference. In electric potential, the unit charge is kept at infinity, but here the unit charge is within the electric field. So more work is done in electric potential, but as compared, less work is done in potential difference. Let work done is equal to W. Q is the charge. Then potential difference. Potential difference means difference between the potential at B and A. So it is very clear that the charge is being transferred from A to B. The potential of A is greater than potential of B. VA is greater than VB. So we can, for measuring the potential difference, this will be VA minus VB, because smaller will be subtracted from greater. It will be equal to W upon Q. The difference in representation of the formula is this, and another difference is of infinity and within the transfer of charge within the electric field. These are the two differences. Now based on this, based on electric potential, I defined you 1 volt, but based on this potential difference, the definition of 1 volt will be slightly different. Based on potential difference, the definition of 1 volt will be the potential difference between 2 points is said to be 1 volt if 1 joule of work is done in moving 1 coulomb charge from one point to another point. The unit for electric potential and potential difference is same, 1 volt. There is no difference. Electric potential is represented by volt, unit will be volt. The electric potential unit will be represented by volt, and the potential difference is also represented by volt. There is no difference in unit, but there is difference in the diagram and the formula of representation. Now instrument used for measuring potential difference. There is an instrument which is used for measuring the potential difference, and this instrument is known as voltmeter. This voltmeter is represented by this sign. This is the representation of voltmeter in any circuit. So suppose this is the conductor, or we can say that it is a load in the circuit, and if we want, suppose this is point A and this is point B, and if we want to measure the potential difference between point A and point B, then voltmeter is connected in parallel. This is parallel. And voltmeter, why voltmeter is connected in parallel? This question can be asked in your board examination. It is connected in parallel because voltmeter has high resistance and hence it takes negligible current from circuit. What is electric current? What is electric current? Electric current is represented by small I. We know that the relation between the charge and the current is Q is equal to IT. Q is charge, I is current, and T is time. So it means I is equal to Q upon T. Based on this, we can define the current. In this formula, if t is equal to 1 second, then I will be equal to Q upon 1. It means I is equal to Q. So based on this concept, we can define the current as it is the amount of electric charge passing through a given point of the conductor in 1 second. It is the amount of electric charge, this electric charge Q, passing through a given point of a conductor in 1 second. We have assumed t is equal to 1 second. So this is the definition which is based on this formula by assuming t is equal to 1 second. Now, SI unit of electric current is ampere and it is represented by capital A. Now, we can define ampere, 1 ampere. Definition of, जैसे 1 वोल्ट की definition दी थी वैसे 1 एम्पियर की definition भी दे सकते हैं. Definition of 1 ampere. When 1 coulomb charge flows through any cross section of a conductor in 1 second, the electric current flowing through it is said to be 1 ampere. When 1 coulomb charge flows through any cross section means, suppose this is the part of a wire. You know that wire is cylindrical in shape, and if we cut this wire like this, then this circular portion of the wire, circular face of the wire is said to be cross section. This is cross section. So when 1 coulomb charge flows through any cross section of a conductor in 1 second, 1 coulomb charge flows in 1 second means if Q is equal to 1 coulomb, T is equal to 1 second, then current I will be, we can represent by capital I or small I, it doesn't make any difference. So I will be equal to, in place of Q, we can write 1 coulomb, and in place of T we can write 1 second. So coulomb per second is ampere. Coulomb per second is ampere. So based on this formula, we are able to define 1 ampere. Now, one ampere is the SI unit, but smaller units are 1 milliampere. It is represented by 1 small m capital E, and 1 milliampere is equal to 1 upon 1000 ampere. This you have to remember, because in numerical if you get the current value in the form of milliampere, then according to rule for before doing any numerical you have to convert all the units in SI. So this you have to remember to convert the given milliampere into ampere. So we can write it as 1 milliampere is equal to 10 to power minus 3 ampere. You can remember like this also. And another smaller unit is 1 microampere. Micro is represented by mu. Microampere, it is equal to 10 to power minus 6 ampere. This is microampere. 1 microampere is 10 to power minus 6 ampere. 1 milliampere, this is milliampere, is equal to 10 to power minus 3 ampere. And like voltmeter, there is an instrument used for measuring current, and this instrument is known as ammeter, or we can say as ampere meter. Commonly it is called ammeter. So this ammeter is used in series with the circuit. Suppose this is conductor and the current start from the source, and if we want to measure the current flowing in the circuit, then we can measure by using ammeter in series. Why we are connecting in series? Because ammeter is connected in series to the circuit, because it has low resistance. This is also very common question asked in always, means every year, almost every year, either voltmeter is asked or ammeter is asked. Why we are using ammeter in series, why we are using voltmeter in parallel? So both you have to remember. Voltmeter we are using because voltmeter has got very high resistance, that's why it is used in parallel, and ammeter we are using in series because it has got low resistance. Thank you.